start streaming.
I'm going to go live here.
I'm going to go process this again. I'll be downstairs, Mom.
Oh, here, can you take this? Pew!
I'm going to aim the fan up the stairs.
Okay.
It's audio.
All right, guys, welcome to Math Thursday. Welcome to Math Thursday, where you have your live math teacher on call right here, ready to answer your questions and get into it. So, for the most part on this channel, we focus on pre-algebra through algebra 2, maybe some pre-calc a little bit. And so, we've already got a question, special right triangles. Okay, we can definitely get into special right triangles. Let me just clear my boards. So as I was saying, we are mostly like pre-algebra through algebra 2, pre-calculus. But if you have a question that's more advanced maths like calculus or into some like more advanced statistics things, pop your questions in the chat because we have a really great community here that will help you out. Okay. All right, so our first topic is going to be special right triangles. So special right triangles for Andrew. I think it's Andrew. All right, so special right triangles they're not that special. They are special in that, so all right triangles have to exist within like a certain, their side lengths exist within a certain relationship, right? And we call that the Pythagorean theorem. So in order for it to be a right triangle, right? If we've got a right triangle, we've got our leg and our other leg and our hypotenuse, right? So our hypotenuse is always the longest leg. The hypotenuse is always the longest side, and it's across from the 90-degree angle. Okay, so your leg squared plus your leg squared has to equal your hypotenuse squared, or the square of your hypotenuse. Okay, so this is what we've got going for us just with the Pythagorean theorem. Now, special right triangles take it kind of a step further. So what special right triangles do is they talk about there's two special right triangles that we focus on. Okay, so the first special right triangle is a 30, 60, 90 triangle. And what that means is that is referring to the angles that make up those triangles. So this one would be 30. This one is 60. Okay, so we have a 30, 60, 90 here. Okay, now beyond just fitting in with the Pythagorean theorem, okay, it's got another relationship. It's got a special relationship with the side lengths where you could actually recognize that it is, not only is it a right triangle, but it is also a 30, 60, 90 triangle. Elle, we can totally do trig. I know Ben, can you say, what do you mean trig sub? I'm not sure what you are referring to, but if you guys give me a little bit more of like what kind of trig you want to do, we can get into it. Okay, it's a really good segue into trig because this is what the whole unit circle is based on. Okay, so we have 30, 60, 90. Now we know that this is still going to be true, right? We still know that leg squared plus leg squared equals hypotenuse squared. But more specifically, if you have a 30-degree angle and a 60-degree angle within your right triangle, the side that's across, well, they're going to exist in a specific ratio. Okay, so the ratio that exists here is if this side across from the 30 degree is 1, okay, the hypotenuse is 2. Okay, And then this leg over here across from the 60 degrees is the square root of 3. Okay, so it always exists that way. So we can take that ratio. So the 30, 60, 90 ratio is a 1 to root 3 to 2. Okay. I like to write it this way because it's going from least to greatest. So you don't think like root 3 and 3, it's kind of tempting to think that like the root 3 is bigger than the 2, but it's not. It's smaller. Okay. So if that's the case, if it's always going to exist in this ratio, it doesn't matter what one of my sides is. The other two are always going to be in that ratio. So if I said this is 4, right? This side is 4. This side is 8, right? The hypotenuse would be 8 because it's 1 to 2. And then this side would just be 4 times root 3. And that's it. Right? So they're always going to be in that ratio there. Okay? So we've got 4. So this is the side. So the side that's across from the 30 kind of sets at like what your 1 is. Right? And then everything else is kind of multiplying by that value. So a lot of times what you'll see is you'll see that across from the 30 is A because that's the 1. So then the hypotenuse would be 2A. And then this across from the 60 degree would be A times root 3. Okay. So if you can remember this, right? Now, sometimes people will put in X's here. I tried to stay away from that when I'm teaching because it can get really confusing when you're solving for like missing variables and stuff, right? So that's why I prefer to use A. But yeah, so the 30, 60, 90 is always going to be a 1 to root 3 to 2 ratio. Okay, now the other special right triangle that we lump in with this is a 45, 45, 90. So I'm going to write this. I'm going to actually write that ratio here so we have room. Okay, so 30, 60, 90 is 1 to root 3 to 2. Okay, so that's the 30, 60, 90. And let's look at the other one. Okay, so the other one is 45, 45, 90. So these two angles are congruent. And since we know it's a 90-degree angle, because I said it was a 90-degree angle, we know that each of these is 45. So 45 and 45. Okay. Now going back to sort of the basics of when you first start talking about angles and side lengths, right? We have to talk about how the angle determines the side length across from it. So if these two angles are congruent, then these two sides also have to be congruent. Okay? So here, we're going to set these both as A. Okay? And then the hypotenuse is A times the root of 2. Okay? So the 30, 60, 90 is the root of 3. 45, 45, 90 is A root 2. Okay? So these exist in a 1 to root 2 ratio. Okay. So how do we remember this? There's a lot of different ways to remember it. The way that I personally remember it, I don't know, it just kind of works for me, is because mainly the main thing is, there's kind of two main things as I start thinking about it. Okay, so the first main thing to me is it root 2 or is it root 3, right? That's a big thing that you have to remember. So for me personally, I always think about, okay, root 2 goes with the one with two identical angles. So root 2 is with the one with two 45-degree angles, okay? And then I just kind of remember that like there's not two of them with A root 2, so these must be A and A. That's sort of a loose way to remember. But main thing is like the root 2 goes with 45 and 45 because it's two of the same angle. Over here with root 3, the 3 is stuck with the 30 degrees. So 3 and 3. That's just kind of how I remember it. Again, it's not great, but it's something. Another way that I just thought about was if you're not struggling with remembering root 3 or root 2, but remembering which one has like the hypotenuse of 2a and the hypotenuse of a root 2, I mean like, so 2 is bigger than root 2, so maybe like 60 degrees is a bigger angle than 45, 45? That might be a way, right? I don't know. You know, Joseph, actually a lot of people struggle with this. And so like, that's great that it was easy for you, but it's not easy for everybody. So that's why we just kind of go over things. And a lot of times you just kind of need a quick refresher and then you're all set. Sometimes you need to go over things multiple times. That's why I'm here. Okay. So I do teach in a school. I teach high school math. I teach primarily sophomores and juniors, so 10th and 11th grade. Okay, let's see. I am a real teacher, yes. Okay, I know. How do you find a missing side length by only using the angles of a right triangle? Oh, okay. So we can kind of talk about that. Oh, sorry, Nate, this says leg, not log. This says leg. That's okay, no worries. Okay. All right, so finding the missing side length of a right triangle. Okay, so we can actually do this in two ways. I'm going to show you first with just using Pythagorean theorem, and then we're going to do some trig ratios. Okay, we'll get into a little bit of trig here. Okay, so we're kind of moving away from the special right triangles, so we'll kind of put those off to the side for now. So somebody had a good question about like, how do you tell with which one's the A and which one's the B, right? For A squared plus B squared plus C, or A squared plus B squared equals C squared, right? So that's the Pythagorean theorem, which is A squared plus B squared equals C squared. Okay, now the reason that I say, well, I tend to stick with this, which is leg squared plus leg squared equals hypotenuse squared, okay? Because it doesn't matter which one is A and which one is B. If you're not, well, let me say, if you are not dealing with angle measures that are also labeled, right, it doesn't matter which one's A and B. But that's a whole other story that we can get into. But for now, if we're just focused on Pythagorean theorem, that's why I tend to stick with leg squared plus leg squared equals hypotenuse squared, because it doesn't really matter. The letters don't matter, okay? So I'm gonna say leg squared plus leg squared equals the hypotenuse squared, okay? So I just like to refer to it as the legs instead of A and B, okay? All right. Okay. So if I have two sides, right? So let's say this is 7 and this side is 8. We'll start off kind of simple, right? So 7 and 8. It's kind of a little hard to see. Okay. All right, so 7 and 8. All right, now what I'm going to introduce now is, some of you may have noticed that our live streams this month are being sponsored by NumWorks. NumWorks is a really great graphing calculator that you can use. It can do everything that all the other calculators can do, but I have found it to be much more user-friendly. It's a lot easier than having to memorize a bunch of keystrokes and where things are. It's just really simple and streamlined, and it looks pretty cool. A couple of my favorite things are that it will automatically give you like a simplified fraction and a decimal whenever you're dividing things. And you can also, anytime you put in square roots or radicals, it will simplify them for you. It's great. It's really nice and easy. And I use this calculator all the time in my classes. I always encourage my students to get this calculator too. And teachers, those of you who are teachers out there, can actually go onto their website and get a you can register and get a free calculator. They will send you one of these graphing calculators for free, just to try out and just to kind of help spread the word. So click the link in my bio and everything, and you can, they're also doing a giveaway. So anybody, not just if you're a teacher, but anybody can enter the giveaway, enter the raffle there. I can't remember if I'm supposed to call it a raffle or a giveaway. I think it's a giveaway. But enter the giveaway, you could win a free graphing calculator, and this thing is pretty awesome. Okay. Let's see. All right, so back to this. So let's see. So 7 and 8. So these are my legs, and the reason I know they're my legs is because they make up the right triangle. Okay, they make up the right angle in the triangle. So we're gonna do, okay, Joseph, you need to go. Bye. Okay. So we've got 7 and we've got 8. So we're gonna we need to figure out what this is, right? So we're gonna call this X. There we go. So I've got 7 squared plus 8 squared. Now, again, it doesn't matter if it's 7 squared plus 8 squared or 8 squared plus 7 squared. It doesn't matter. It's all gonna go, okay? So 7 squared plus 8 squared is gonna equal my hypotenuse squared, which is X squared, okay? All right, so now I've got this. I've got 49 plus 64 equals X squared. So 49 plus 64 is 113. So 113 equals X squared. Okay, so now in order to get my 113 equals X squared, to get my X by itself, I need to take the square root of both sides. Okay, so if I take the square root of X squared, I get X. And if I take the square root of 113, I probably just get the square root of 113. Yep, it's square root of 113. So again, on my NumWorks calculator, it's kind of hard to see. I'll change the brightness a little bit. But when you put in square root of 113, it just gives me this 10.63014. So I know that it's not going to be simplified at all. Okay. All right, so let's see. Permutations and combinations. Let me know what your quiz is. Maybe put in a couple of things, like maybe some problems that you might have. Okay. Jonas, they're the best. I know, they're so good. Ugh. Once you, it's so unfamiliar first, but then once you start really playing around with it, it's so much better. It's so clear and easy to do. Okay, I think Joseph's gone. Good. All right, Ixnay, the binomial problems. Can you tell me what you mean? What do you mean by binomial problems? Okay, there's a big swath of binomial problems. All right, so we'll do law of signs in just a minute. Okay, so this means that X would be the square root of 113, which if you need to round it, it's about 10.6. Okay, so that's how you can find the side of a missing triangle without, of a right triangle, okay, using the Pythagorean theorem. Okay, now if we talk about finding a missing side and we start throwing in the angles, okay, so let's do, okay, if I have a right triangle, okay, and let's say that this angle is 42 degrees, the meaning of life, 42 degrees. And we'll say that this leg here is 10, okay? So it might feel like we don't have enough information to solve this problem, but we actually do. And the reason, well, we do if we start to use trig. So trigonometry is, it was the bane of my existence when I was in high school. Oh, It just didn't make any sense to me. It felt like it was just magic, right? So, but trig is pretty simple, but remember, simple does not mean easy, right? So simple can still be challenging, right? So, let me get this one. Okay. So trig is based on, again, kind of with those special right triangles, right? How the special right triangles have those specific relationships. What also happens is that every right triangle has a specific relationship. Actually, every triangle has a specific relationship between angles and side lengths, right? So there is only one right triangle that exists that has this side of 40, or this angle of 42 and this side length of 10. There's only one. And we can use our trig ratios to figure that out. Okay, so in trig, I'm just gonna blow through this really quick, but there are so many of my videos out there where we go over a little more detail over what the right triangle trig ratios are. Okay, but when you look at a right triangle, okay, and let's say this is your theta, okay, so theta, which is like a 0 with a little slash through it, theta is like your angle of interest, okay? So this side is your opposite, this side is your adjacent, and this side is your hypotenuse, okay? The hypotenuse is always the hypotenuse. So those of you who are kind of like in trig right now, this should be pretty familiar to you. If you're here just kind of browsing and kind of like seeing like, oh, what's going on, okay? And you're kind of confused by this, that's okay. Stick with it. Let's see what you can learn, right? Now, the ratios of all of these sides have a specific relationship, okay? The relationship between all of these sides have a specific ratio based on that angle, okay? Now, what we've got is we've got 3 main trig functions. There are technically 6, but the other 3, we don't usually work with those very much. They're kind of weird. But the main 3 are sine. So sine of theta is the ratio between my opposite and my hypotenuse. Cosine theta is the relationship between my adjacent and my hypotenuse. And then tangent theta is the one that's missing. So tangent theta is my opposite over my adjacent. So the way that we remember this is so ka toa. So ka toa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There we go. Okay, so ka toa. So in this case, get it? Okay. So in this case, here's our theta. Okay. Let's say if we're trying to figure out this one. Well, we can try, let's figure out both. Why not? Okay. So we can start with either X or Y, but we're going to use our trig ratios to figure this out. So I'm going to fill in what I know and I'm going to solve for what I don't know. Okay. So I know this angle and I know this side length. Now this side length is my adjacent. So in order to figure these out, I am going to have to use like cosine if I wanted to figure out Y first. Or I'm going to need to use tangent if I want to figure out X first. The reason is because cosine is the adjacent over the hypotenuse, and that would include Y. Tangent is the opposite over the adjacent, and that would include X. So we can take our pick. Let's start with tangent. Why not? So let's start with tangent. So we're going to say tangent of 42 equals X over 10, because X is my opposite and 10 is my adjacent. Okay, and now tangent 42 is a number. If you just put it into your calculator, like your beautiful NumWorks calculator, you can put it in and you can just get, like, tangent 42 is 0.900404. It's a really long, ugly, irrational decimal. Anyway, but what we can do is instead, we can just leave it as tan 42, and I'm going to multiply both sides by 10. So now I know that 10 times tangent 42 is going to give me my X value. So I can take my calculator and I can do 10 tangent 42, enter, and I get 9.004. So I'm going to call that x is approximately 9. Okay, I'm going to turn down my brightness on here. That might make it a little bit easier. Just see. Okay, why did I multiply by 10? The reason I multiplied by 10 was because this was my side length. So this 10 here is this 10 here. Okay, so this 10 here is this 10 here. So then I multiplied by 10 to get x by itself. Okay, so this calculator is called a NumWorks calculator, and they are sponsoring our lives this month. It is a really, really, really great calculator. It makes it really easy to do all sorts of things. The graphing, oh my gosh, finding the zeros, you literally just type in like find the zeros and it takes you right to all of the zeros. You don't have to set any boundaries or do any guesses or anything like that. Okay, all right. So this is how you would use just a trig ratio to find your opposite. But it works the same no matter which ratio you're going to use. So to find y, now I always recommend not using a rounded value. Go back to the original problem and use the length that they gave you. So in this case, let's see. So to find y, I would do, so if I'm trying to find y, so 10 is still my adjacent, y is my hypotenuse. So I've got my adjacent and my hypotenuse would be cosine. So cosine theta, or sorry, cosine of 42 equals my adjacent, which is 10, over my hypotenuse, which is y. Okay. So this one, okay. And guys, if you are interested in entering a giveaway for a free graphing calculator, click the link in my profile or in the chat and you can enter there. But also, if you are a teacher, you can go to their website, same link. You can go to their website and you can send them your information and they will send you a free graphing calculator. Highly recommend to do that. And then just start playing around with it. It's, you know, it's a little bit of a learning curve, but not a huge one, right? It's pretty intuitive and very nice. It's designed by educators, so like they get it. There's not a separate negative sign and subtraction sign. It's the same sign. So much easier, right? Okay, so to keep solving this, we're going to multiply by y, multiply by y. So now I have y times cosine 42 equals 10. Now to get y by itself, I'm going to divide by cosine 42 on both sides. So y equals 10 over cosine 42. Okay, so I go to my calculator, 10 divided by cosine 42, which gives me about 13.46. So I'm going to call it 13.5. And those are my sides of the triangle. Okay, so it would be, x is 9 and y is about 13.5. And that's how you can use trig to solve a right triangle. Okay. All right. Okay. Oop, oop, oop. What if it is not a right triangle? How would you find a side length with only an angle and a side? So you could, so if you only have one angle and one side length of a triangle, that's not enough information. You need to know a bit more information, but you can use trig to find the side lengths of other of triangles that are not just right triangles. You can use the law of sines, you can use the law of cosines, and yeah, you can do that. So you can use it to apply. Why can't you use arc cosine? So arc cosine is what you use if you don't have the angle, right? That's the same thing as like the cosine -1, right? So arc, cosine, arc sine, those are if you don't know theta. Okay, so if you don't know theta, then you would be using the arc, cosine, and the arc sine. But in this case, we knew theta, so we didn't need to use that. Okay. All right, so let me scroll back up. Okay, let's see, because I know there were a lot of... let's see. Okay. Okay, so how to find the different angles on a rhombus. Yeah, Max, you can cut it into triangles. Let me get into a little bit of domain and range. But on a rhombus, so just really quickly, on a rhombus is basically a square without the 90 degrees, right? Where all four of these sides are congruent, okay? But none of these angles are 90 degrees. So this angle and this angle are going to be congruent, and these two angles are going to be congruent, okay? So what you can do is, if you're given some information about it, right, you could also use, like, you could kind of like put in some like parallel lines because it's still going to act like a transversal, right? But if you're given like one angle, I mean, if you're given one angle, it doesn't matter which angle you're given, you can figure out all of them. So if you're given like this is 100 degrees, right? We know that this is 100 degrees. And then here, if we think about this as a transversal, right, with these two lines being parallel, so if that's 100, these are consecutive or same side interior angles. So this would be 80 degrees. And so this would be 80 degrees. How much do I make per year? Not enough. I think that's the story of every teacher's life, right? Not enough. Okay, so that's kind of how you find the angles of a rhombus. Okay, so let's do a quick once over with domain and range. Okay, and I'm going to kind of talk about domain and range in sort of a, not like a more necessarily like advanced type of function, but I'm not going to do it just like with a linear equation. Okay, so let's do a let's do just a quadratic here. Okay, we'll say that's my vertex. Okay, all right, so we've got this quadratic equation, right? So my vertex here is at 1, 3. Domain, no matter what kind of function you are talking about, okay? Domain is, oh, person who's asking for a Pythagorean theorem. Go over to YouTube and rewind it. We did a whole thing on Pythagorean theorem like 25 minutes ago. Okay, so domain is all the x values, okay? That's what it is all the x values that this is going to be passing through. Okay, now with this parabola, right, if it keeps going up, 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 it's also going out, 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 right? So it's going up and out for infinity, right? So it's going to pass through all of my x values, right? So my domain usually, so there's lots of different ways to write domain, but you could say that like x such that you could do like all real numbers like that. That's what that means, is that the x is going to be all real numbers. You could also do, so that's one way of writing it. You could also do interval notation, which is where you would say x is all values from negative infinity to positive infinity. So those are two different ways of writing the same thing. It just means that X is all real numbers. It's all the possible values, right? Now range is usually the one that's a little bit more challenging because range is the possible Y values, okay? More challenging until you get into like more advanced math, like pre-calc and things like that. Then the domain and the range can be a little tricky. But anyway, so the range, when we look at this one in particular, so again, we're looking at all the possible Y values, right? So domain is X, range is Y. And I don't know why, but the way that I remember it is thinking about something being rangy. I don't even know what rangy means. But range Y, I don't know. Rangy just sounds like a word. I don't know. It's a weird time of year, guys. I gotta come up with something. Okay, so we're looking at all of the possible Y values, okay? So now my Y values, notice they do not come down here, right? They are only going from here up. So my Y value, the lowest that it can be is 3, okay? So again, if we write it like this, we could do for Y such that Y is greater than or equal to 3. Okay, that's one way of writing it. You can also write it going from 3 to infinity. Okay, so positive infinity. Now this is going to have a curved parentheses, okay, because you can't graph infinity. You can't plot infinity on the time. This side is going to have a square bracket, okay? Now the reason it has the square bracket is because it can equal 3. Okay, so that square bracket means that it includes 3. That's interval notation. So it's greater than or equal to 3 is what that says, right? Okay. Okay. So surface area and volume, I've seen a lot of people talking about or asking about surface area and volume. And with surface area and volume, so volume, when it boils down to it, if it's a prism, right? If it's the same shape on both ends, like a rectangular prism or a cylinder, right? Whatever prism it is, the volume is always going to be the same. I don't know why I wrote a W. The volume is always going to be the same. The volume is the area of the base times the height. So whatever side you consider to be the base, right? Maybe it's the end, right? If it's a cylinder, right? Obviously the base is the circle, right? You would find the area of that and then multiply it by the height or the depth or however you want to think about it, right? Now, if it's a pyramid, again, or a cone, right? No matter what shape the base is, okay, if it's a pyramid, let's see, pyramids are hard to draw. So something like this, okay? So if it's a pyramid, that's not bad, okay? The volume, because it doesn't go to the two sides and then like fill in, it goes from one side to a point, okay? It is 1/3 of the area of the base times the height. That's it. Okay, now sphere is a little bit weird. Sphere is its own thing, okay? But any prism where you have the same two shapes on either end and it's filled in, that's gonna be the area of the base times the height or the depth, however you wanna think about it, right? If it goes from a side to a point or from a face to a point, right, from a shape to a point, okay, that's gonna be 1/3 the area of the base times the height. Okay, now the surface area formulas, I mean, ultimately what you're looking at is, sure, the surface area formula will shorten up so you can just do like a couple of keystrokes on your calculator, maybe your NumWorks calculator. But really what you're looking for is you're trying to find the area of every single face, right? So you're trying to find the area. And so what you would do is you would need to think about like what's really helpful in these are those net drawings, right? So if I was looking at a rectangular prism like this, right, I would have like all the sides kind of rolled out, right? So I would have 4 sides rolled out like this, right? And then I have 2 squares here, like this, right? That would kind of be the net for that thing, okay? And then I could find the area of each of these shapes and add them all together. That's what surface area is it's how much area is actually being covered, okay? Okay. So other than that, like other than kind of like grasping the basic concept, like with the formulas, it's just the formulas. Okay, it's just the formulas. It's hard to, they're tricky to memorize. There's a lot of them. But if you understand the basic concept and you forget the formula, you're gonna be set, okay? All right, let's see. David, it's really hard to show graphing a sine function on here just because the screen is so small. Let's see. So I can't really help you with that. Brendan, I can give you a very basic overview of logs. So you're Rami, the domain and range in an inverse square root. So the domain and the range are always going to be the same basic concept, okay? So with the inverse square root, do you mean where you have the so when you have something like if you have a square root function that kind of looks like this, right? Okay, so it goes from there up there. So let's say that this point is 1, 2, 3, 4, 1, 2, 3, 4, 5. So this point is -4, +5. Okay. I know that's a really rough graph, but so the domain is still going to be all of my x values, and my range is still going to be all of my y values. Okay, now this gets into a little bit of a challenge, just because like if, you know, when you start getting into more advanced like polynomial graphs and things like that, we're going to have some things like asymptotes and limits and things like that, but still the domain and the range remain the same. So looking at this though, I don't have an x value that's going to be less than -4, right? -4 is my highest, no, -4 is my lowest x value, okay? Now it can include -4, so my x value, so my domain is all x values such that, that's what that vertical line means, x is greater than or equal to -4. If I needed to do this in interval notation, I would do a square bracket because it includes -4 to infinity. Okay. Now my range, again, is my y value. So 5 is my lowest y value. So y is going to be greater than or equal to 5. And again, I'm going to go from 5 to infinity. There we go. Ooh, 12th grade taking calculus. Put in, so rotational solids. Rotational solids is great. That's not something that we really get into here. Tribunals is another thing we don't really get into here. But you guys can pop your question into the chat because somebody else might be able to help you out with that. But we mainly focus like on pre-algebra through algebra 2, a little bit of pre-calc a bit. All right, good. I'm glad that that worked for that. Okay, so let's see. Factoring trinomials, binomial theorem. Okay, let's see. Oh, man. Okay. All right, I see quadratic square. So, Mr. Fallout, sine, cosine, and tangent. If you go over to YouTube, you can rewind because we just went through a bunch of sine, cosine, and tangent practice problems not too long ago, about 30 minutes ago. Okay, so factoring trinomials is something that I'm seeing a lot in here. Okay, so trinomials. So exponential graphs actually is kind of similar to that. So an exponential graph and an exponential equation, the way that that works, I'm just going to give you a quick little thing about that, is that an exponential function, okay, is something, for example, like you've got f of x equals 2 to the x power. Okay, so 2 to the 0, so 2 to the 0 is 1, right? 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. And I can't get the rest. But now, if you think about like 2 to the negative 1 would be 1/2. So that would be here. 2 to the negative 2 would be 1/4, which would be here. It keeps getting cut in half and half and half and half and half. So here, this graph is never going to actually cross 0. It's going to get closer and closer and closer to 0, but it's never actually going to reach there. The fact that it's never going to cross there, that's called an asymptote or an asymptote. But it's never going to cross it. That's why. I could add something to this, right? I could add 1 and it's going to shift it up and down. That could change where your asymptote is. But generally, this is kind of what you're talking about when you talk about an exponential growth or decay model. So the exponential decay, right, would be kind of going just the other way. Okay. Okay. Oh, Algebra 2 final next week. Okay, a, b to the x, a is the initial and b is the rate. Yeah, if you're doing the exponential growth, yep. So a is the initial and b is the rate, and it's usually, yeah, the rate would be like if it's growth. So with the exponential growth, so you would have like your exponential growth is your starting number. I don't even remember what variables we usually use. But so it's the growth would be like your start times 1 plus your rate, whatever that is, and then to the t, which would be your time, right? I can't remember what we use for start. I don't think it's P. It might be, I don't think it's X. But anyway, okay. If it were exponential decay, you would do 1 minus r to the t, right? So that's usually if you're talking about like population growth or demise. So when you're looking at, so I want to talk about like on this NumWorks calculator, you can, again, if you guys are just joining us, I know we're just about to wrap up, but this week's or this month's live streams are being sponsored by NumWorks calculators. Again, this is a really user-friendly calculator. It was designed by teachers. It's beloved by teachers. And if you've got, if you are a teacher, you can go onto their website and you can put in your information, and they will send you a free calculator to try out. It's pretty cool. Even if you are not a teacher, you can go onto their website and you can enter the giveaway that they are sponsoring, and they will draw a name and send you a free calculator as well. So they're really, really fun to use, very user-friendly, very easy to navigate and all of that, which, you know, when you're taking an exam, especially when it's a timed exam, efficiency is key, right? You want to be as fast as you can be. These calculators will simplify radicals for you right there, okay? You can find the zeros of an equation. Boom, boom, boom. Easy peasy. Okay, you just got certified in middle math. Yay, that's awesome. That's so exciting. Congratulations. Go on to NumWorks and get your free graphing calculator. Go do it. Okay, but that's so exciting. Congratulations. I'm always excited to hear about new math teachers because it's the best job ever. All right. Rate of change is the rate of change. Do you mean for the rate of like the growth? I'm assuming that you're talking about the rate of growth or decay, and that's usually given to you, or you have to use the, you would need to, kind of depends on the situation, but if you're given a bunch of data, you could use your calculator to find a line of regression, and that'll give you the exponential equation. Best writing utensil for math. Oh man, I am such a, I'm a mechanical pencil person, and I can be very specific. Here's my pencil bag. So best writing utensil for math. I love the Bic 0.5 millimeter. I like a thin lead. I don't like the 0.7. I like the 0.5 millimeter. And then if I'm writing in a pen, oh man, these pens, they're called Muji pens, M-U-J-I. They're a 0.38 tip. Oh my God, they are so good. They're gel pens. Oh, they're my favorite. So yeah, so those are just being as specific as I can be. I also do, when I'm making my notes for my classes, I like to, if it's something that I would put like in bold, I use these Uniball Signo or Sino. I don't know. These are like my thick pens, but they're still like a 0.7 or something. I like a really fine writing utensil. So I really like mechanical pencils because I don't like having to sharpen it all the time. But yeah, so I'm just I'm all for Bic 0.5 millimeter. I wish they made an even thinner one. Okay, one last quadratic. Let's see, solve for roots x squared minus 6x minus 16. We can do that, and I can show you guys all sorts of ways to solve these quadratics. So we have x squared, oh no, x squared minus 6x minus 16, and we'll just call that equals 0. Okay, so x squared minus 6x minus 16 equals 0. So when we're looking at this, there's a few different ways to solve this. So we are solving a quadratic. Okay. Few different ways we can do this. We could do completing the square. Woohoo! We could do quadratic formula. It's kind of messy on this one. And we could factor this. Okay, so I'm going to start. I always start with checking, like, can I factor this? And factoring something just means that you're writing it out as a multiplication problem, because then if you've got two things that are multiplying together to equal 0, one of them has to equal 0 in order for that to happen. So it makes it really easy when you're multiplying things together to equal 0, then you can just figure out like, okay, well, what are my values that are going to make it equal 0? Okay. So we can do this by factoring. So factoring, we are going to look at what two numbers multiply to negative 16 and add to negative 6, which is my number here. So what two numbers multiply to negative 16 and add to negative 6? It can be done. Negative 8 and positive 2. Good. Okay, so negative 8 and positive 2. So since this x squared doesn't have a number in front of it, I can just go ahead and I can use my numbers, my -8 and +2, which these are my two values that multiply to -16 and add to -6. So what I can do, these are my two numbers that are going to be my binomials that would multiply together to equal this, right? I can do x times x, which is x squared, x times 2, which is 2x, -8 times x, which is -8x. So 2x minus 8x is -6x, and the -8 times 2 is -16. Okay? Now, if these multiplied together equals or need to equal 0, then one of them, if one of them is equal to 0, then wait, 6 and 3. Was that 6 and 3? No, 6 and 3 would not also work because it doesn't multiply to 16. Okay? So now one of these would have to be equal to 0 in order for this whole thing to equal 0. So either x minus 8 equals 0 or x plus 2 equals 0. So if x is 8, this whole thing is going to equal 0. If x is -2, this whole thing is going to equal 0. So those right there, somebody was asking finding roots. These are my roots. Okay, my roots are -2 and 8. Okay, these are my zeros. These are my roots. These are my solutions. It's all the same thing. These are my x-intercepts. It's all the same thing. Okay, when we're working with quadratics, all of those things mean the exact same thing. Okay? So this is when, oh good, they went back to the puzzle thing. This is when you've got, like 1 is in front of the x. Now, if there's another number in front of the x, you would have to do a couple of different things. You can use, there's a lot of different ways to go about factoring those. So you can do, there's the AC method is kind of the one that's most frequently used, I would say, or most frequently taught. There's also like an X method that you can do. There's the area model that you can do. There's a lot of different ways to do that for factoring when A is not 1. Okay. Okay. All right. I'm going to do regrouping in different bases. Do you mean for like exponents or I can't, guys. It's after 9. Okay, so now this one, let's take this one and let's do completing the square because somebody had asked for that before. So x squared minus 6x minus 16. So one of my favorite things to do is actually completing the square. Completing the square is a really fun way to solve quadratics. And it is the easiest thing to do. Well, it's easiest to do when this is 1 and this is an even number. Okay? If it's not that, I mean, you can do it, but you really don't want to. It's really ugly. Okay? But so what I'm looking for is something called a perfect square trinomial. So a perfect square trinomial is something that would be like, oh, if I had x plus 4 squared. If I square that, that would be x plus 4 times x plus 4, which is x squared plus 4x plus 4x plus 16. So we have x squared plus 8x plus 16. That is a perfect square because we know where it came from, but also because half of 8 is 4. 4 squared is 16. That's how I know this is a perfect square. So if I had x squared minus 6x plus 9, well, half of -6 is -3. -3 squared is +9. This is also a perfect square. This would be x minus 3 squared. Okay. Now looking back at this one, I've got x squared minus 6x minus 16. If that was a +9, it would be a perfect square trinomial. And what we can do is we can actually force it to be a perfect square trinomial. Okay? So I just need this to be a plus 9, right? So if I add 25 here, negative 16 plus 25 is going to give me plus 9. Right? And then I've got my 6x minus an x squared. Now I can't just add 25, right? I've got this here, right? And that's now a perfect square, but I can't just add 25 because it wouldn't be the same thing. I can't just add 25 to one side and not the other, but I can even it out, right? If I add 25 to both sides, it's still the same thing. So now I've got x squared minus 6x plus 9, and I know this is a perfect square because half of negative 6 is negative 3. Negative 3 squared is 9, okay? So I can rewrite this as x minus 3 squared equals 25. Now, since I have this side as a perfect square, I can now square root both sides. So if I square root both sides, I get x minus 3 equals positive or negative 5, right? Because negative 5 squared is also 25. And now that I've got this, I know that either, this is where I would kind of split it, right? I know that either x minus 3 equals positive 5, or x minus 3 actually equals negative 5. So I add 3, I have x equals 8, or x equals negative 2. Now that's the same thing that I got from factoring, right? So these are just different ways of doing this. The slip and slide method is pretty good. The slip and slide method is a good way of working these out also, okay? All right, guys, I am out of time for tonight, but special thanks to, there's a lot of easier ways, yeah. Okay, so special thanks to Numworks for sponsoring our live streams this month. If you are interested in entering the giveaway for a free graphing calculator, please click the link and do the stuff. Also, teachers, don't forget, teachers, go get your free graphing calculator. It's a really remarkable tool, okay? And if you guys have any questions or you need tutoring, one-on-one, anything like that, let me know. Click the link and do the stuff. And sign up for our summer boot camp. So I will be teaching a once a week, hour-long Algebra 1 boot camp, kind of getting ready for going into Algebra 1. This is looking for middle schoolers, 7th, 8th, 9th grade. Maybe parents, you might want to brush up on your algebra skills to help your students or help yourselves or help your kid. Sign up, click the link, do the stuff, and we'll see you next week for Math Thursday. Bye. Consistently 80-ish.